Download this code from codegive.com, link in the description below. OK, let's dive deep into partitioning problems, including an in-depth tutorial with code examples in Python. What are partitioning problems? In essence, partitioning problems deal with dividing a larger set, often a set of numbers, elements, or objects, into smaller subsets or groups based on certain criteria or constraints. These problems often arise in various domains, from resource allocation and load balancing to data mining and combinatorial optimization. Common types of partitioning problems. Here's a breakdown of some common types, along with explanations and code examples. 1. Subset sum problem asterisk. Asterisk description asterisk given a set of non-negative integers and a target sum s, determine if there exists a subset within the given set whose elements add up to exactly s. Asterisk approach asterisk dynamic programming is a very efficient way to solve the subset sum problem. We create a boolean table dpij, where dpij is true if a subset of the first I elements can sum to j, and false otherwise. Asterisk code, Python. Asterisk explanation asterisk. 1. Initialization asterisk the dp table is initialized. The first column dpi0 is set to true for all I because an empty subset always sums to 0. 2. Iteration asterisk the code iterates through the ARR and the possible sums from 1 to target underscore sum. 3. Decision asterisk for each element ARRI1 and each sum j, it checks if ARRI1 is greater than j. If it is, we can't include it in the subset, so dpij inherits its value from dpi1j. Otherwise, we have two choices, either include ARRI1, in which case we need to find a subset that sums to j, ARRI1 using the previous elements, or exclude ARRI1, in which case we need to find a subset that sums to j using the previous elements. 4. Result asterisk dp and target underscore sum contains the answer. 2 equals sum partition problem asterisk. Asterisk description asterisk given a set of integers, determine if the set can be partitioned into two subsets such that the sum of elements in both subsets is equal. Asterisk approach asterisk this problem is closely related to the subset sum problem. Calculate the sum of all elements in the set. If the sum is odd, the set cannot be partitioned into two subsets with equal sums. If the sum is even, the problem reduces to finding a subset with a sum equal to half the total sum. Asterisk code, Python. Asterisk explanation asterisk. 1. Total sum asterisk the code calculates the sum of all elements in the array. 2. Odd sum check asterisk if the total underscore sum is odd, it's impossible to divide the array into two subsets with equal sums, so the function returns false. 3. Even sum and subset sum asterisk if the total underscore sum is even, the target sum for each subset is total underscore sum / 2. The code calls the subset underscore sum function, defined earlier, to check if a subset exists with that target sum. If it exists, the array can be partitioned, otherwise, it cannot. 3. Minimum difference subset sum asterisk. Asterisk description asterisk given a set of integers, divide the set into two subsets such that the absolute difference between the sums of the two subsets is minimized. Asterisk approach asterisk similar to the equal sum partition, we can use dynamic programming to solve this. We'll create a table dp where dpij is true if a subset of the first I elements can sum to j, and false otherwise. Then, we find the largest sum j such that dp and j is true. The minimum difference is then abs, total underscore sum, j equals abs, total underscore sum, 2 asterisk j. Asterisk code, Python. Asterisk explanation asterisk. 1. Initialization asterisk similar to subset sum, we initialize the dp table. 2 iteration asterisk the code iterates through the ARR and possible sums. 3 finding max possible sum asterisk after the DP table is filled, we iterate backwards from total underscore sum / 2 to 0 to find the largest value for j for which DP and j is true. This value j represents the maximum possible sum that a subset can achieve. We iterate backwards because we want the sum closest to total underscore sum / 2 to minimize the difference. 4 calculate difference asterisk abs, total underscore sum, 2 asterisk max underscore sum underscore possible, gives the minimum difference between the two subsets. 4 k partition problem, partition to k equals some subsets. Asterisk description asterisk given a set of integers and an integer k, determine if it's possible to partition the set into k non-empty subsets such that the sum of elements in each subset is the same. Asterisk approach asterisk this problem is generally NP complete. We can use a backtracking / recursion approach. First, calculate the total sum of the array and check if it's divisible by k. If not, it's impossible to partition into k equals some subsets. Then, the target sum for each subset will be total underscore sum / k. The recursive function explores all possible ways to fill the k subsets. Asterisk code, Python. Asterisk explanation asterisk. 1 initial checks asterisk calculates the total sum, checks if it's divisible by k, and computes the target underscore sum. 2 used array asterisk the used array keeps track of whether an element has been included in any subset so far. 3 recursive function, can underscore partition underscore recursive. Asterisk base cases asterisk. Asterisk k underscore remaining equals 0, if we've filled all k subsets, we've found a solution. Asterisk current underscore sum equals target underscore sum, if the current subset's sum is equal to the target, start filling the next subset, decrement k underscore remaining. Asterisk current underscore sum target underscore sum, if the current subset's sum exceeds the target, this branch is invalid. Asterisk recursive step asterisk iterates through the ARR starting from start underscore index. For each unused element. Asterisk marks the element as used. Asterisk recursively calls can underscore partition underscore recursive to try including the element in the current subset. Asterisk if the recursive call returns true, meaning a valid partition was found, return true. Asterisk if the recursive call returns false, meaning including the element didn't lead to a solution, backtrack by unmarking the element, used I equals false. For start recursion asterisk the initial call to can underscore partition underscore recursive, k, 0, 0, starts the search for a valid partition. 5 graph partitioning, min-cut / max flow based. Asterisk description asterisk involves dividing a graph into 2 or more subgraphs while optimizing some objective function. A common goal is to minimize the number of edges cut, min-cut, or maximize the flow between 2 specific vertices, max flow. Graph partitioning has applications in computer network design, VLSI layout, and social network analysis. Asterisk algorithms asterisk. Asterisk Store-Wagner algorithm asterisk a deterministic algorithm for finding the global minimum cut in an indirect graph. Asterisk Kargas algorithm asterisk a randomized algorithm for finding the minimum cut in an indirect graph. Asterisk Ford-Fulkerson algorithm asterisk a classic algorithm for solving the max flow min-cut problem. Asterisk example, Ford-Fulkerson while implementing the full algorithm requires more code. Here's a snippet showing the general idea of using Ford-Fulkerson to find a maximum flow, which is related to finding a minimum cut. Asterisk important considerations for graph partitioning asterisk graph partitioning algorithms can be computationally expensive, especially for large graphs. The choice of algorithm depends on the specific problem, the size of the graph, and the desired trade-off between accuracy and speed. Libraries like networks in Python provide tools for graph manipulation and can facilitate the implementation of more complex graph partitioning algorithms. Optimization techniques for partitioning problems. Dynamic programming as demonstrated in the examples, DP is often effective for solving subset sum and related problems, providing optimal solutions in polynomial time. Greedy algorithms while not guaranteed to find the optimal solution for all partitioning problems, greedy algorithms can be useful for finding approximate solutions quickly. For instance, a greedy algorithm for the minimum difference subset sum problem might repeatedly add the largest element to the subset with the smaller sum until all elements are assigned. Backtracking can be used to explore the solution space for K-partition and other more complex partitioning problems. However, backtracking can become very slow for large input sizes. Pruning the search space is critical to improve its efficiency. Branch and bound an optimization of backtracking where we compute bounds on the objective function and prune branches that cannot lead to a better solution than the current best. Heuristics when exact solutions are computationally infeasible, heuristics can be used to find good quality approximate solutions. Examples include simulated annealing, genetic algorithms, and taboo search. Integer programming many partitioning problems can be formulated as integer programming problems and solved using solvers like Plex, Gurobi, or open-source solvers like CBC. Key considerations for choosing an algorithm. Problem type identify the specific type of partitioning problem, subset sum, equal sum partition, K-partition, graph partitioning, etc. Size of the input dynamic programming is generally suitable for smaller input sizes. For larger inputs, heuristics, approximation algorithms, or specialized graph partitioning algorithms might be necessary. Optimality requirements if an exact solution is required, dynamic programming, for some problems, or backtracking, with pruning, might be appropriate. If an approximate solution is acceptable, greedy algorithms or heuristics can be faster. Time and space complexity consider the time and space complexity of the chosen algorithm, especially for large input sizes. Further learning. Introduction to Algorithms by Thomas H. Corman et.al., a comprehensive textbook covering dynamic programming and other algorithm design techniques. Algorithm Design by John Kleinberg and Eva Tardos, another excellent textbook on algorithm design, with a focus on real-world applications. Online coding platforms LeetCode, HackerRank, Geeks for Geeks provide a vast collection of partitioning problems to practice with. NetworkX documentation if you are interested in graph partitioning, the NetworkX library in Python is a valuable resource. This comprehensive tutorial should give you a solid understanding of partitioning problems and how to approach them. Remember to consider the specific problem constraints and the trade-offs between solution accuracy and computational complexity when choosing an algorithm. Good luck.